Today we are learning about forces, and this exercise is forces acting on a football sled. So you have your football player here, and he is pushing the top left of the sled to move it for his football drill. See, football sled there, football player there. Alright, so the first thing you do when doing a forces problem is you want to draw your free body diagram. And I've drawn it in red. And the three forces we have acting on this in this problem from the football player pushing the football sled is you're always going to have gravity, which is pointing downward, and gravity is your mg force, and then the force pushing outward at a horizontally is your magnitude force, and then the force pushing upward, which is right here, is your contact force, where is the hands of the football player pushing the sled. So after you draw your free body diagram, you want to label your forces. And because we know in this, because I'm telling you, the forces that are given is the magnitude force, which is the weight of the sled, is 750 newtons, and it is directed downward. So you do your mgx, which is the gravity, and the xward position is 0, and your mgy in the vertical position is negative 750 newtons. So then after that you label your magnitude force, which we know because in this problem the magnitude that the football player pushes with is 450 newtons. So you label them here, and your f of x, which is your magnitude force, is 450 newtons, and in the f of y direction it is 0 newtons because he is not pushing anything up or down. So next on this, because we drew our free body diagram, we have to talk about our contact force. And our contact force is right here. And what you draw is, this is your contact force going out, and then it makes a triangle, and it makes a right triangle right here. And these are listed. This is your y-axis, and this is your x-axis. So in the y and x-axis, now we set the x and y components right here for the net force, and we had to set them each to 0 because the chest is at an equilibrium of the football player. The football player's chest right here is at an equilibrium. So what we do is we draw a triangle out. We put theta here, and the rule, because this is a right triangle, is that the rule here, what you told us in class, is that this is theta, and so these two angles are equal to each other. So we draw the sum of f of x is mgx plus fx plus cx equals 0. So it equals 0 because the gravity force in the x direction is 0. Then it is a positive 450 newtons because the force that we are pushing with right here is 450 newtons in the positive x direction, and then you plus the contact force because that is what we're trying to find and we don't know yet. So then we put it to equal 0. So then the sum of the f of y is, you have gravity in the y direction plus your force in the y direction plus your contact force in the y direction equals 0. So then the gravity force in the y direction is negative 750 newtons plus 0 because there is no force for the sled at the y direction, and then you add the contact force of y right here, and you set that to 0. Then you must solve for the contact force x and the contact force y. So contact force x equals negative 450 newtons because you solved to set c to 0. So you have to solve for that, and you have to get C by itself. So you get negative 450 newtons. Same thing for contact force in the y direction. It gives you 750 newtons. So because it is an equilibrium, the chest is, then we must work out for C. So C right here is so you have your Cx, which is given, and your Cy, but we need to find the hypotenuse. So you have Cx squared plus Cy squared, and then you plug your x and your y in. You have negative 450 newtons from where you got right here, and you have your 750 newtons right there. And you work this out, and the final answer right there is 870 newtons. And then right here, to find for that, you have to do the inverse. Theta equals the tangent inverse, which is opposite over adjacent. So this equals tangent inverse 750 newtons over 450 newtons, because you put the opposite angle over the adjacent angle, use those two there, and it gives you 59 degrees. So the contact force and the magnitude of the direction are all reasonable based on the graphic addition, so we can be confident that we did not make an error such as a sign error with one of the components. So you want to just go back and check your work and make sure and read through it and make sure you did everything right. But in conclusion, the contact force is due to the floor of the sled. The contact force to the sled is due to the force of the floor is 870 newtons and directed 59 degrees above the leftward horizontal. So that is my forces problem of the day. I hope you enjoyed it, and I'll see you next time.